and Star Wars references are also okay. Questions?
So forces to the left, it's always negative. Forces to the right, it's always positive.
No.
No.
Forces to the right is positive just because I said so here.
Okay.
It can change every single problem.
Gotcha.
Now, some textbooks will, instead of doing the I hat, J hat, which is what I will do, I hat, J hat, K hat for 3 dimensions, they'll do X hat and Y hat. X hat and Y hat. I don't care for that because we will get into plenty of problems where things are not horizontal and vertical. You can solve problems like that. I mean, if I have blocks going down a ramp, I'd probably want to make down the ramp positive. So, this is something special, we'll call that the X hat direction. And some people still do. I'll call that the I hat direction, and perpendicular to that, the J hat direction. So when you're dealing with the, what are called unit vectors are symbolized by the hat on top. If you were dealing with unit vectors, they are defined by the person solving the problem. Typically, you set it up and you live with it for the rest of the problem. And then you can change it for the next one if you wish. All right, that was a simple enough problem. Let's make it 2-dimensional. I have 2 forces acting in the box. Force number 1 is 3 newtons I hat minus 4 newtons J hat. So let's see. So we've got a box right here, and it is pointing. Let's make I hat that way, and I'll make J hat that way. They are perpendicular to each other. They will be perpendicular for the duration of this course and the next course. They will stay perpendicular to each other. If you go far enough in physics, you get to the point where you start dealing with coordinate systems that are not at right angles to each other, and that is for many years down the road. I have force number 2 acting on the box, and we'll just say 6 newtons I hat plus 7 newtons J hat. And I want to add these 2 forces together. I want to figure out what the total force is. So, you add them. And so, you add them. So what is this total? Plus or minus? Plus. Yeah, you add like terms. You add the I hats together, you add the J hats together. Now, both of them are in newtons. Writing like this is perfectly fine. Let's say you just feel like, I don't feel like writing the letter N twice. That's just way too much. Can you get away with just writing it once? Depends. Both of them have units of newtons, and so I could also write it as 9 I hat plus 3 J hat, but if I want to use newtons just once, I have to put parentheses around the whole thing to indicate that both of them are newtons. If you don't have the parentheses there, then you've lost units here. So either of these are acceptable. Now, I mentioned trig not too long ago, and you might be going, wait a second, where's the trig? Don't worry, it's coming. Perhaps not today, but it's coming. Now, this I hat, J hat, perpendicular to each other, this is known as rectangular notation. Rectangular notation, the math is simple enough. You add the like terms, just like in Algebra 1. You add the x's, you add the y's. The other form of adding these, which it does usually involve trig, is polar form. Polar notation. I've got that 3 newtons I hat minus 4 newtons J hat, given my coordinate system right here that I defined. That is 3 this way, 3 newtons this way, and 4 newtons this way. So my vector, my sum, there's my double print letter. That is the resultant right there. It is the sum of those two smaller vectors. That is a right angle because I hat and j hat are perpendicular to each other. What is the magnitude of the hypotenuse? Or how would you find it? Okay, Pythagorean theorem. And if you do that, you'll find that the magnitude is 5 newtons. The direction, I need to figure out what that angle is right there. Now, this brings in the trig. Other ways of doing it, but I think this is probably the most common way it's introduced. SOHCAHTOA. We have 3 basic trig functions. We have the sine of an angle is equal to the opposite length over the hypotenuse. The cosine of the angle, where that angle there is theta, is the adjacent, the A, over the hypotenuse. And the tangent of theta is the opposite over the adjacent. So the way you would set this up from a trig point of view is think of this as a room with 3 sides in it. I'm standing in this corner. The opposite wall is the one that I'm facing. This is the opposite. The adjacent is the one that's not the hypotenuse that I can touch. That's this one. So the tangent of theta is equal to 4 over 3. I'm solving for theta though, so I need to get rid of the tangent. So I have to somehow undo the tangent. So how do you reverse tangent?
Cotangent?
Not cotangent.
Arc.
Yes, arctangent. So if I take the arctangent of tangent of theta, if I do it to one side, the math people tell me I have to do it to the other. Arctangent of tangent, this just gives me theta. And arctangent of 4/3, well, that's a calculator exercise, but it's about 53 degrees. Just because it's a 3, 4, 5 triangle. So I would express this first vector in polar form. I need to express the magnitude and the direction. So the magnitude is 5 newtons. The direction, well, if I just said 53 degrees, which direction is 53 degrees? I know from my drawings that way. We will stick with the math convention. You don't need to redefine this unless, of course, you want to. 0 degrees is this way from your point of view. 0 degrees, positive 90, positive 180, positive 270, positive 360, or 0. If I go in the other direction, it's negative. So I would write this as 5 newtons, negative 53 degrees. That's F1. So we managed to get a little bit of trig there. But now the next instructor is here, and she's going to throw us all out on our ears unless we stop the learning. She's always suppressing our learning. Anyway, Lacox says it's time to go, as well as the person in the hallway. And I guess I will see you on Friday. If school is not in session, then expect to see an email from me with alternate instructions. No doubt it will be educational.
Let me get your number.
Sure.
What? You can't do physics by yourself?
What? Maybe physics by yourself?